Fire department.
Yes, 3146 Cherry Road. Fort Lincoln, fire in the basement townhouse.
That basement townhouse.
Yes.
3146.
3146.
3146.
I am at 3144. It's next door.
Oh, okay, we'll check it out then.
We were responding for the Cherry Road house fire, Memorial Day weekend, and it was reported as a townhouse fire. As we were en route, we then learned that it was a basement fire, a working fire, and so we came into the block. We noticed a haze of smoke. You could smell it in the air, and one of the neighbors ran out into the street to point to the house to tell us where to go. So at that point, we knew that we were dealing with a real fire. We were excited about being able to do what we do as firefighters, put fires out. But at the same time, we were concerned about the residents of the house and making sure that they were safe and being able to get them out safely.
6 on the scene, we got a 2-story row, heavy smoke showing. That one. 26 is on the scene, a 2-story row with heavy smoke showing, 0022.
Upon arrival, coming to the front of the structure, we saw a lot of black smoke billowing out of the front door, and that gave us a firm indication that we had something serious going on inside, but we didn't know exactly what we were encountering. So myself, Lewis Matthews, my co-worker, and the officer of Engine 26 went in through the front door. We crawled down the hallway through intense heat and smoke. But then we came to an area in the back of the townhouse where we had visibility. So we had obviously passed by the source of the smoke and heat, but we weren't exactly sure where it was located. So we were still looking for the fire at the source. As I turned to over my left shoulder, I looked and I saw a doorway, which obviously was the basement door. A flash of flame came through that door, and the room instantly blackened down, and we had intense heat and smoke on top of us. So intense that we couldn't move away from it. We moved deeper into this structure trying to move away from the heat, but at the same time it just blanketed us where we could not get it off of us at all. I myself had lost connection with the hose line, and I believe Lou as well, because I was asking him if he still had the hose. Well, it was one of the strangest things that I'd ever experienced, because it was an eerie quiet. You could actually hear the plastics in the room starting to crinkle. The heat was intense. We were moving and scrambling, trying to get away from it, so that's how I lost connection with the hose line. And shortly after that, when things started to calm down, there was someone in the room other than Lou and myself that was screaming. I thought it was someone who was inside of the house before us, maybe one of the residents on the upper level. And so the screaming was a screaming of intense pain, and then the screaming stopped, and whoever that person was, which we later found out was Tony Phillips, had fallen to the floor.
Okay, at this point, don't worry about the extension. I want you to have engine 17 and truck 4 work together and look for firefighter Matthews of engine 26.
So we searched around, found the hose line. I was telling him that we really needed to make our way out of the structure because something had gone obviously wrong. I rolled on my back, fired a straight stream at the ceiling to try to cool the room down and follow the hose line out. I received second and third degree burns over 65% of my body, and I was in the structure from the time of the heat entering into the room where we were until leaving about 2.5 minutes. On the fire ground, when they cut away my clothes, I saw my skin from my stomach go with my shirt. I saw the skin from my fingers go with my gloves, but I still didn't know the extent of those injuries. So when I was at the hospital, I can recall being received at MedStar. I was still awake. I was talking to the nurses and the doctors while I was sitting on the gurney, and then I believe at some point they made the decision to rush me into surgery. And the next time that I woke up, I was in my room with a room full of firefighters and family staring at me, and I was staring back at them, not knowing what was going on. I experienced well over 35 surgeries from skin grafting and regrafting. I spent 2 months in ICU, 2 months in the step-down unit. The 2 months in ICU, the first month they gave me 5% chance to live because of the extent of my injuries and my age at the time. The second month they gave me 50% chance to live. And here I stand now because of the great, phenomenal job that they did at the hospital center. I had smoke coming out, fully bursting out of that door because I had no visibility going in.
And was it under pressure, like pushing out?
It was pushing out, yes.
So you advanced the hose line, you and Lou?
So Lou had already started his advance, and I followed the hose line in to catch up with him. And so I had my hand on the hose line, my shoulder on the wall as I crawled down. And I actually caught up with him right about at the living room area inside the building.
At any point, were you able to determine that the fire was in the basement?
Not at that point. I knew that the report was the fire was in the basement. It was reported as a basement fire. And as I was crawling down the hallway, we came to the living room area and we had visibility. So at that point, I started to look for the basement door. And that's when I turned and looked over my left shoulder and I saw the doorway.
Right. So this is kind of the whole topography thing.
Yes.
Really came to light how we really had to emphasize the difference between the front and the rear because it really affects the flow paths.
It does.
And that's the importance of getting the 360s. And it was you probably, from your perspective, weren't able to see the different, the layout of the building, right? I mean,
so
that it was 3 stories in the rear and 2 in the front.
I wasn't able to see that on the approach as we were coming in from the apparatus, but because I was familiar with the townhouses here, this is our first due, so I did know that in the rear you had a 3-story, what looked like a 3-story building, and then the front, the 2-story, because of the basement exit.
Right. Were you able to come back here after the fire? Did you ever come back here?
This is my first time at the rear of the structure. Everything that I've done at this point was on the front. There's the phenomenon that black fire, which describes exactly what this is. It's the energy, the heat energy that comes from the fire, but you don't actually have flame. And one of the things I recognized while I was in there was that the heated gases at the ceiling were dropping down, which I could see, but I can also see the flashes of flame in that smoke, which told me at that point that the room was preparing to flash. With the amount of heat that we had in there, with the crinkling of the plastics that I could hear when it was dead silent, those were the warning signs that I had at the time. But then when Dan came back with the study that they had done and showed how the fire had progressed, how the energy had moved up the stairs and into the room where we were, it just all came together. The science, which a lot of times is disputed by those who are practicing, but the science made sense.
Joe Morgan just provided us with a very unique insight into the Cherry Road fire. He was exposed to a high thermal insult that day, which resulted in him being burned over 65% of his body. He was fortunate to live to tell about it and share that information with us. I arrived on the scene at Cherry Road about a day later to assist the DC Fire Department Reconstruction Committee to help them understand the fire dynamics of that incident. This incident was one of the first times that the fire dynamic simulator was used to try to simulate the fire to get a better understanding of the fire flows and how that fire responded to ventilation and the creation of flow path. Let's go through that study and look at the results. The Cherry Road incident was reviewed by 3 different reports, one by the District of Columbia Fire Department, one by NIOSH, and one by NIST. The NIST report focused on the fire dynamics and was based on the fire dynamics simulator, a very early version of that program. As we look at the layout of the townhouse, we see that we have the basement level and the first floor covered. The second floor had bedrooms, and the windows to the bedrooms were open, so the controlling vents really were the opening from the first floor to the upstairs, and then the openings on the first floor being the front door and the kitchen window, as well as the doorway from the basement. Looking at the basement, the only opening to the exterior was the sliding glass door, which was closed at the initiation of the fire and then was opened during the fire event. The area of origin was in the ceiling in a light fixture in the basement. The basement was finished. It had wood paneling and combustible ceiling tile, basically composing the basement, carpeting on the floor, and a wood bar built in and a few pieces of furniture, as you can see in the drawing. When you approach the townhouse, it showed 2 levels on the front side of the house and 3 levels on the rear side of the house. There was a steep drop-off as you walked around the one side of the house. One of the challenges for arriving crews is if you entered from the opposite side of the structure at the rear, you walked in from street level on level ground and came to the basement level. So some of the firefighters that arrived on the scene did not have to walk down a hill to get to the basement level, which generated some confusion as to what was the first floor. As we open the gate to the backyard and take a look at the photo here, we can see that the basement sliding glass door has been cleared out, and that was vented when there was a request to search the first floor. Those windows were taken, and crews from a rescue company crawled in to look for victims. The sliding glass door on the first floor level was attempted to be vented with a ladder. It did not break. A ladder was left in place, and then that crew left in place for the second floor, and that crew went back to get another ladder and were going to vent this window. However, by the time they returned, the basement had already flashed over and flames were going up the back side of the house. The door failed later in the incident. When we look inside the basement, we can see that the fire damage in the basement is consistent with a flashover condition, meaning that we have damage that is fairly equal burn damage from the ceiling all the way down to the floor. Looking at the area of origin, we could see that we had a void space basically above the basement ceiling. The top of that void space was composed of the subfloor made of plywood from the first floor. Then there were parallel cord trusses in place, which allowed heat to move freely from the front of the townhouse to the rear. There was no fire stopping in the floor, if you will, in that void space. And then attached to the bottom of the parallel cord trusses were wood furring strips with 1 foot by 1 foot combustible wood fiber ceiling tiles attached to that. So there was a significant amount of fuel load located in the ceiling of the basement, and of course, one of the worst places to have a high amount of fuel load is in the ceiling of a fire compartment. Moving around to the front of the structure and looking in through the front door, we look down the hallway and we can see that there's still gypsum board paper on the walls, on the ceiling. It's not burned off. So we did not have flaming combustion in this area in the entry hallway and the hallway moving back toward the rear of the building. When we look over at the stair, we can tell that the carpet is a light color carpet. We just have soot damage on the carpeting going up to the stairs. Again, no evidence of high heat going up the stairway or any fire in the area of the stairway. Looking at the portion of the front door that we can see in the photo on the right, we can tell that only the top quarter of the door was exposed to enough heat where the plastic molding on the steel door got hot enough to melt and distort. Walking down that hallway and going toward the rear of the structure, we can see there's a lot more damage as we move to the rear. We're basically standing next to the door opening from the basement looking at these photos. And what we can see is that the carpet on the floor is not burned. Again, we have a lot of paper on the gypsum board that has a heavy amount of soot on it but has not been burned away. We see that the sofa in the rear against the back wall has some indications of burning toward the top of the sofa. The seat cushions provide evidence of pyrolysis, not actual flaming combustion. And then we can see on the arm and below there's still virgin material, upholstery material on it that hasn't been burned. Firefighter Matthews' body was found in front of that sofa. Firefighter Phillips' body was found toward the center of the photo. Most of the furniture has been cleared from the center of the photo, as you see here, predominantly because the floor was spongy, the floor was soft. It had started to lose its structural integrity. The Reconstruction Committee, at the time the DC Fire Department had formed up, had a number of questions that they wanted somewhat of an engineering response to. They had 5 firefighters on the first floor with significantly different injuries. Why? The room where the line of duty deaths occurred had limited thermal damage. Why? Both the fatalities had charged lines and they never opened them. Why? So the report, titled "The Simulation of the Dynamics of the Fire at 3146 Cherry Road Northeast, Washington, D.C., May 30th, 1999, focused on the use of the fire dynamics simulator to create a computer-based model of the Cherry Road townhouse. Here we see the basement and the first floor. And the way the model is laid out, you see the little red dot over the kitchen window. When that dot turns green, or any dot turns green over a vent, that indicates that that vent is now open. At the start of this model, the front door, seen on the right-hand side of the model, was open at the start of the fire as the occupants, the start of our modeled fire, as the occupants had left that door open as they left the structure. About 17 minutes after midnight, the fire department received a call. 2 occupants in the house had smoke alarm went off, and they noticed there was a fire. The husband went downstairs and saw smoke coming out of the basement. The occupants always kept the door between the basement and the first floor open because the basement was finished. That was part of their home, and they actually had a tapestry hanging over that door. They kept it open all the time. The husband got his wife, and they exited the home, leaving the front door open. They went to a neighbor's house to make the call to the fire department. Within 7 minutes, Engine 26 was on the scene, and the firefighters were entering the front door. In terms of the model time, that's time 0 for us. 2 minutes later, the first floor front window was open. A firefighter from a truck company had gone into the kitchen to clear out the window from the inside. The security bars on the outside had prohibited him from clearing the window completely from the exterior. 20 seconds later, one half of the basement door was open, and then it was estimated it took another 20 seconds to clear the other portion of the basement, the sliding glass door, due to restrictions again with the security bars. In less than a minute, radio reports came from the rear that the basement was fully involved. There were requests coming through at that time asking to apply water. Instant Command knew that they had 2 other engine companies on the first floor of the building headed toward the basement. They did not want to have opposing streams. There was concern about steam injury, and as a result, they did not flow any water. The fire continued to build in the basement, flashing over and then flames extending up to the first floor on the exterior of the home. It's sort of in this interval between the basement being fully involved and the fire extending to the first floor that the firefighters on the first floor that were interior were injured. And then at 300 seconds or 5 minutes of simulation, the simulation was ended. An important thing to note is that there were several models that were run to look at the fire development time. It didn't matter if the fire became ventilation limited in the basement 15 minutes before the basement doors were open, or 5 minutes before the basement doors were open, or 90 seconds, or in this case, 140 seconds before the basement doors were open. So we chose the smaller value here just to optimize our computer time when we were running. But there were test cases that were done to show that if you have a ventilation-limited basement with hot fuel gases inside and you're adding the missing component of oxygen to the fire triangle, it will transition to a flashover very quickly. So what we're looking at here is the model view of the structure from the rear of the townhouse. The 2 sliders are on the bottom. They're closed at this point in time. The dots on the vents are red. Firefighters are in the structure making their way toward the rear.
The firefighter is in the kitchen clearing the window, so we have an open door and an open window on the front side of the structure. And now we see that the sliders are open, and that quickly results in the temperatures increasing. So the blue, the temperatures are in degrees C, the temperature scale to the right of the screen. Blue is approximately 70 degrees Fahrenheit, and the red is on the order of 1,500 degrees Fahrenheit. So you see the temperature range there. So blue is good, red is bad. And you'll notice that once the windows were vented, we have a nice neutral plane set up at the doorway. 2 firefighters made entry after the windows were vented. They indicated that when they made entry, all they saw was smoke. They saw no evidence of fire. They believe they got in 10, 15 feet or so into the basement. They started to see fires on the floor. It looked like little campfires. We believe that these were the ceiling tile that had fallen down, and the fresh air coming in low to the floor, carrying the oxygen, allowed them to reignite. They looked up and they saw a glow in the overhead, and they knew it was time to get out. When they turned around, they were able to see firefighters' boots and flashlights outside. They termed this as somewhat miraculous. They said it was like somebody had carved a tunnel in the smoke, or someone had made an opening for them so they knew right how to get out and make a quick exit before the flames rolled over their head and out of the building. As we can see, this neutral plane here, that the gas velocities going in the building, entering low to the floor, were moving about 10 miles an hour. And that basically provided fresh air and moved the soot out of the way, making that clear opening for the firefighters to have visibility to crawl out of the space prior to it flashing over. What we're looking at here is a temperature profile that stretches from the front door down the hallway toward the rear of the structure. In the center of the upper level is an area where the firefighter from the truck company that cleared out the window and one of the officers that was in the structure ran into each other as the heat started to build in the structure. Both these firefighters were able to exit by the front door with minor burn injuries. They had some blisters. And we could see that once they got toward the front of that hallway, toward the front door, they were actually in cool convective air. They were below the neutral plane. Fresh air was coming over them and cooling them, taking some of the radiant heat that would be hitting them off of them. And that, in some sense, explains why their injuries were relatively minor. And again, they were able to quickly move and get themselves out of the front door. Now we're going to look at the temperature slice, or the temperature profile, that's centered on the stairway. Firefighter Phillips, Joe Morgan, and Firefighter Matthews were essentially lined up in front of this doorway. And we'll see that as the basement doors are cleared and the basement transitions to flashover, we'll see a very high velocity, high momentum hot gas come up the stairs. It's moving at about 15 to 18 miles an hour, and we see that the momentum of the gas carries it across the ceiling and down the back wall and over that sofa where Firefighter Matthews' body was located. Firefighter Matthews was burned over 95% of his body and fairly uniformly. We can see why that is, as he was in that hot convective flow. Firefighter Phillips, play the video again, we'll see that Firefighter Phillips, who was facing the basement down the door based on where his nozzle was found, received most of his thermal injuries on the front, and his face piece failed him. He pulled his face piece off, and that resulted in his dying at the scene. Firefighter Matthews survived and was taken to the hospital where he lost his life. Joe Morgan was not in a great place, but he was sort of in the middle in that hump area. So he wasn't exposed as rapidly to those high-velocity hot gases. He had some time to react and get the nozzle, cool off those gases, maintain his situational awareness, and follow the line out the front door. That doorway, in effect, acted as a nozzle. One way you could think about it is if you took a hairdryer and turned the hairdryer on full blast and put your finger right in front of the nozzle, you'd feel a lot of convected heat being transferred to your finger. If you moved your finger off to the side, just an inch away from the nozzle, very little heat would be transferred to your finger. These 3 firefighters, perhaps, if they had been located where the lieutenant was, perhaps just to the side of the door or 6 feet over from where they were, they might have had time to respond and make an exit. Given where they were with all that heat focused on them at such a high velocity, it took their time of a safe operation away, that once they got hit with that heat, especially firefighter Matthews, basically he went down and didn't move any further. Why didn't they open their line? Well, with the gases moving at 15 to 18 miles an hour and the townhouse being on the order of 32 to 33 feet deep, that's about 2 seconds for the hot gases that came from the basement to go all the way to the back of the structure. So that's happening very, very quickly. In this portion of the model, we're looking at where's the oxygen. Without oxygen, we cannot have flame and combustion. And what we see here is that we have oxygen-depleted gases filling the upper level. They're at levels well below 10%. So the fire, we don't have a lot of flaming combustion upstairs, which is why the firefighters never saw that visual clue that they were looking for, basically to put the wet stuff on the red stuff. This is a condition, as Joe mentioned earlier, referred to as black fire. The gases are certainly hot enough to be flames and to burn, however, they don't have the oxygen to achieve that.
Cherry Road provided a demonstration of a ventilation-induced flashover. This kind of condition was not familiar to the fire service at the time. They may have experienced it many times, it just didn't have a title. The other thing that the ventilation-induced flashover demonstrated for us was the speed with which thermal change occurs inside the structure. It goes from a thermal environment where the firefighters are okay and they're protected by their turnout gear to an environment that can cause them injury or become lethal in a matter of seconds. So again, this ventilation-induced flashover is the driving force for that change. What caused it? What's the onset? Well, that's demonstrated the real need to understand flow paths. The firefighters in the Cherry Road incident were in the exhaust portion of a flow path, unidirectional flow path where they were located. They were between where the fire was and where the fire wants to go. That's a very high hazard area to be operating. So it points out the need to understand flow paths, intakes, exhausts, as well as the impact of door control and other means to control those flow paths.
As we review case studies, it's extremely important to honor the losses and the sacrifice that were made by considering the lessons learned and adjusting tactics appropriately on the fire ground.